Greetings, everyone, and welcome to God Save the King. I am your host, Tim Kies. I want to thank you for joining me on the Truth Be Told Radio Network, where you can hear my show every Friday night at 10 p.m. Eastern Time. So, as my manner is, really excited about today's show. We got a great show for you today. We're going to talk about some very interesting subjects today. We're going to do things a little bit different. Now, for those of you that have not heard my show before, my show is called God Save the King. God Save the King is a tongue-in-cheek pun. It is a reference to the contrast and the dynamic, the paradox between the legitimate king of the Jews, Jesus of Nazareth, and the Roman appointed king of the Jews, Herod the Great, at the time that Jesus was born. So what God Save the King is about retelling the nativity story in its historical context and correcting the biblical errors along the way. Because unfortunately, the traditional nativity story that we are used to hearing, it kind of grew up independent of the Bible. I hate to say that, but that's really, frankly, what happened is that by word of mouth, the traditional nativity story got handed down, word of mouth, mouth to ear, mouth to ear, mouth to ear, in an historical version of the children's telephone game. And therefore, it just got passed down verbally, and that's what people believed. What did not happen is that it was not passed down based upon rigorous observation of the biblical text. It was passed down strictly as a tradition, and this, ironically, is actually historically verified. See, unfortunately, what a lot of people think happened about the nativity is that, well, Jesus must have told one of his disciples, and then his disciples told one of his disciples, and that one of his disciples told one of his disciples, and then eventually somebody wrote it down. But the problem is that didn't happen. That is not what happened. As a matter of fact, according to the historical record, we know almost nothing apart from the Bible, okay, about the birth of Jesus, specifically the birth date of Jesus, for about 200 years after he walked the earth. It's only once you get into the very early 3rd century AD that anybody even bothers mentioning it. And like I said, the assumption is that the evidence actually got passed down from a reliable source to a reliable source to a reliable source. And unfortunately, that isn't what happened. That didn't happen at all. It literally, no one thought about it for 200 years. And then finally someone said, aha, let's think about when Jesus was born, because after all, we should be celebrating his birthday, shouldn't we? Which ironically is not in the Bible. We're not told to celebrate his birthday in the Bible. It's not simply not there. But someone just went, well, when was he born? And they developed a theory about when he was born. And ironically, it stuck. It just stuck. And it stuck around the end of December. And then eventually that became the 25th of December, which it didn't help. It wasn't I'm going to help out my skeptic friends here for a moment. It was not a deliberate attempt to co-opt the winter solstice. Okay, that is not supported by the biblical evidence until later. Okay, that did happen, but it didn't happen until much later. So it wasn't a part of the choice of what date to pick. Okay, in other words, so Christian authorities did not say, hey, let's deliberately choose December 25th as the date of Jesus's birth so that we can co-opt the winter solstice festivals, worshiping the Roman god Mithras and other, deities and things like that. That isn't what happened. That mix-up did occur later on. It did. It did occur later on, but you're talking 3rd, 4th, 5th, 6th century and later, not early on. Not early on. So that's actually not what I want to talk about today. What I do want to talk about today is actually extremely different. We're going to go in a totally different direction today. We're going to talk about something frankly kind of modern, but kind of ancient at the same time. If you happen to be watching my show on a format where it gives the title of today's show, the title of today's show is, Does Quantum Physics Describe What the Bible Has Been Telling Us All Along? Does quantum physics describe what the Bible has been telling us all along? That's what we're going to talk about today. But before we get there, let me do a little bit of business. Very thankful that you are either watching or listening to my show. Very thankful that you are watching or listening to my show on the Truth Be Told Radio Network. You can help me and you can help the Truth Be Told Radio Network by liking and subscribing in whatever format you're using. So if you're watching me on Facebook right now, please click that like button and follow God Save the King. If you happen to be watching on the Truth Be Told Radio Network website, please subscribe if you would. That really helps us out. That helps me. That helps the Truth Be Told Radio Network. So if you prefer a video format, the best way to watch God Save the King on TBTRN is on Rumble. Go to rumble.com /C/TBTRN. Rumble.com /C/TBTRN. That's the best way to, if you prefer a video methodology, if you want to watch in a video context, right? Now, go to the other end of the spectrum. If you want an audio format without video, but you don't really care if it's a podcast, quote unquote, same thing. Go to not same thing, different. Go to the Truth Be Told Radio Network website and simply click on the big Listen Live button. That way you can listen to God Save the King. You can also listen to a variety of the other great shows that are on the Truth Be Told Radio Network. Plus, if you happen to have a smart device, so whether it's your phone and therefore it's Siri, or whether it's a home device like Alexa, you can simply say, hey, Alexa, play the Truth Be Told Radio Network, and it will go there, right? And then, of course, there is the podcast format. And that's what I want to emphasize for just a moment today. If you really like a podcast format, we are on 12 major podcast platforms. So you can go to the Truth Be Told Radio Network website and click on the podcast tab, and it will show you the 12 major podcast platforms that we are on, and they have embedded links that will take you straight there so that you can either listen or subscribe to the podcast through those formats as you see fit, and then enjoy God Save the King on the Truth Be Told Radio Network the way you prefer to in podcast format. And if you go to either the Truth Be Told Radio Network Facebook page or my Facebook page, all this week we are putting up the links to those podcast platforms. So just check those out. Go to God Save the King, Facebook, Truth Be Told Radio Network, Facebook, and you will see the links to Amazon or Audible or Apple or Anchor, Google Podcasts, iHeartRadio, Pocket Casts, whole bunch of them. Your favorite podcast platform is probably up there. All you got to do is go find it, click on it, subscribe, and that way you can listen to God Save the King on the Truth Be Told Radio Network whenever you want in a podcast format. Now, let's get back to what we were talking about. I told you we were going to do something different today. We are going to do something different today. We're going to talk about something really different, okay? And now for something completely different. Very, very different today. I want to actually talk to you about quantum physics. Now, this comes with a giant disclaimer. I am not a quantum physicist, not by a long shot. I am not that kind of scientist. I am a theologian. I am a historian. I do consider myself pretty well educated when it comes to the Bible and to biblical history and ancient history. Okay, so if you want to refer to me as an expert in those areas, that is not a stretch. I know a fair bit about the Bible. I know a fair bit, certainly, about the Nativity. It is absolutely my area of expertise. I know and understand biblical hermeneutics extremely well. So, and I understand history very well and the historical method and how to do historical research. Now, but I'm not a scientist in the sense of I'm not a biologist. Okay, I'm not a chemist, I'm not a physicist. So everything I'm about to tell you about quantum physics, I can tell you because of, guess what? The internet. Okay, you can look this stuff up just as readily as I can on the internet and learn about quantum physics if you want to learn about quantum physics. But I'm going to relate it to the Bible, and I'm going to relate it to the Bible in a particular way, in that we're going to ask the question, does quantum physics describe what the Bible has been talking about for a bare minimum of 2,000 years, if not more, if you include the Old Testament? When I say 2,000 years, obviously I mean the whole Bible, Old and New Testament. But if you want to talk about just the Old Testament, and frankly, the book of Genesis plays significantly into this discussion, well, then you're talking more like 3,000, 3,200 years ago is probably when the book of Genesis was written down for the first time. So 3,000 years ago, that's a long time that the Bible has been talking about the same subjects that quantum physics is now revealing to us. Now, the first thing we probably need to do is talk about what is quantum physics. And like I said, I am not an expert. I am not a physicist. I am not a quantum physicist. I'm not a Newtonian physicist. Okay. We're going to talk about this a little bit, but I am talking in generalities and in broad strokes. Therefore, if you know more about the subject than me, okay, great, fair enough. I may not cover everything in hyper precise detail, because my point here is to help your theology. It's to help your faith, frankly. It's how you apply your biblical faith is really what I'm after. And the reason I'm sharing this is because this is what happened to me. I gained some insights from quantum physics that made me go, look at that. That's what I've been believing for years. That's what I've been believing for decades. And I believe it because it's in the Bible. So what I'm talking about here is, does quantum physics help us understand certain subject matter in the Bible? So what is quantum physics? Well, let's start by talking about classical physics, or what could be called Newtonian physics. What is Newtonian physics? What is classical physics? Well, physics is the observation and understanding of physical material, the behavior of physical material. You observe, you watch, you conduct experiments, you observe physical material, and then you are concerned with the movements, the motions, the reactions, and the behaviors of material items. Okay. So for example, if you went to the top of a 10-story building, right? 10 feet per floor, 10 stories, 100 feet up. And then you go up there with 6 bowling balls, a 10, a 12, a 14, a 16, an 18, and a 20-pound bowling ball. And then one by one, you drop those bowling balls off the top of that building. Because we understand classical physics, because we understand the behavior of physical objects, you can measure using the height of the building, the weight of the bowling ball. You can measure how fast it's going to fall, how fast it's going to accelerate, and therefore the impact energy that bowling ball is going to hit the ground with. Now, the reason I know that, which is very interesting, is because I also happen to be a black belt in karate. And many years ago, when I would teach my students how to break things, right? How to break a board with your fist, or a concrete block with your fist, or a kick, right? I always taught them this is just simple physics. This is accelerating the mass of your fist to go through that pine board. See? So that is so force equals mass times acceleration. It's not just mass times speed, it's mass times acceleration. You have to accelerate your fist through that board. So using our example of the bowling ball, you're measuring the acceleration of the bowling ball from 100 feet up to measure its impact energy when it hits the ground. That is classical, or what we sometimes call Newtonian physics. Okay, there you go. It's simplified. It's vastly oversimplified, but it's easy to understand. Physics, classical physics, concerns itself with the behavior of physical objects. There you go. Okay, so what is quantum physics? What's the difference? What is the difference between quantum physics and, classical physics and quantum physics? Well, quantum physics is when you put matter under a microscope and you look at the building blocks of that matter, right? So if I've got a coffee cup here, or I've got my drink here that I sip out of occasionally, that glass, interesting that I should use that phrase, this container is not glass, it's plastic, okay? But let's imagine for a second we're a coffee cup, all right? So if you've got a coffee cup here, that coffee cup could be made out of ceramic clay that has been fired and glazed, right? It could be made out of ceramic, it could be made out of glass, it could be made out of plastic, or it could even be a paper cup, right? Well, any one of those materials is made up of molecules and atoms that are that material, okay? So if it's ceramic, it was at one time, it was clay or mud, and then it was formed into a shape, and then it was put in a very hot oven called a kiln, where it was fired, and then potentially it was glazed so it would be smooth on the outside. But the bottom line is that it is made out of molecules and atoms of a certain substance, clay, mud, from the earth, right? But if you put those particles, you put those atoms under a very powerful microscope and you zoom in, what you find out is that there are subatomic particles. If you go through standard high school physics class, they're going to tell you that the standard building block of everything is the atom, right? And then they'll tell you all about how atoms are put together with neutrons and electrons and protons and the whole thing. But then, like I said, if you put an atom under a microscope, under a very, 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 very powerful microscope, you will discover that there are these subatomic particles. I already mentioned several of them. That is the proton, the neutron, the electron. Those are all kinds of subatomic particles, right? But there are, according to physicists, right, according to the various websites all over the web and stuff like that, there are about 200 different kinds of subatomic particles. Okay, did you catch that? Over 200 kinds of subatomic particles. That's a lot. And I can only list off a handful because, once again, I'm not a scientist. I'm just doing this to try to help us, frankly, to understand the Bible a little bit. So there's protons, there's neutrons, there's electrons, there's photons, there's bosons, there's leptons, hadrons, quarks, neutrinos, and like I said, 200 other subatomic particles. But the reason I'm bringing this up is I want to get to the definition of what quantum means, right? And this is a layman's definition. If I take any object, right, or especially if I take, for example, like a length of rope or string, I can cut it in half, and then I can cut it in half, and then I can cut it in half, and then I can cut it in half. And I can keep cutting it in half, 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 and I can keep cutting it in half until eventually there actually gets to a place where I cannot cut it in half anymore. And this actually happens in our physical universe, right? This actually happens in our physical universe that there are divisible units of length, mass, energy, and time. Let me say that again. There are divisible units of length, mass, energy, and time until you get to a point where, guess what? They are no longer divisible. There comes a point where you can't do it. You mechanically, maybe theoretically you can, but mechanically you cannot, and maybe even theoretically you can't either. There comes a point where they are no longer divisible. This is what we refer to as a quanta, okay, or quantum, right? Quantum is the singular, quanta is the plural. So a quanta, right, okay, quantum is it's the smallest indivisible piece of anything, the smallest individual piece. So the smallest length, smallest indivisible, pardon me, the smallest indivisible length, the smallest indivisible measure of mass, the smallest individual measure of energy, or the smallest indivisible measure of time. These are called quanta, and this is what makes up quantum physics. Okay. Now, why am I saying this? Why am I bothering? Well, because we're going to use some really interesting words tonight that are mostly from the Bible, but are very much interrelated or possibly described by quantum physics. Okay. So the words we're going to look at from the Bible, okay, that we're going to talk about from the Bible are words like eternal or eternity or everlasting or heaven or spirit, okay? Or how about this? How about omnipotent or omniscient, or for our purposes today, omnipresent, right? That one's going to come up a little bit later on. So these are words we find in the Bible: eternal, eternity, everlasting, heaven, spirit, spirit realm, right? We might talk about from the beginning or from the foundation of the world, one of my particular favorites. Omnipotent, omniscient, omnipresent, things like that. But then we're going to compare them to words like quantum, quantum field, or dimensionality, multiple dimensions, dimensionality. Or check out this word. This is the word that is kind of going to be the pivot point of everything we talk about today, which is the word infinite, and of course the corresponding word finite, right? Because when we talk about the things of God, when we talk about eternity, when we talk about everlasting, things like that, we're talking about infinity, aren't we? Or aren't we? Those are kind of the questions we're going to look at today, because these are the words, these are the adjectives used to describe quantum physics, right? So so Tim, what are you getting at? What are you getting at here? Let's talk about this, because what we're talking about here is a very, very small particle, because most of the time when we think about God or we think about heaven, we think in largeness. We're not thinking in smallness, we're thinking in largeness. As a matter of fact, it's a very common thought pattern. I'm not going to say that it's wrong, but it's certainly incomplete. Okay. It's a very common thought pattern to think of God, who is eternal, as being out there, that eternity is out there. And I'm pointing away from the camera, and I'm pointing out into space, that we think of God in his largeness, in his infiniteness, as being out there. Okay, he's out there. Or another way that we do it is, this is a very common one, is that we think of eternity as simply limitless time. Okay, and that is not what eternity means. It is a small portion of what eternity means, but it's not what eternity means. And that's a very common thought pattern, is that we think eternity simply refers to limitless time, that eternal life. See, there it is. Now we're starting to get there, right? That if you believe in Jesus, then you are granted eternal life. Well, eternal in that context is more about quality than it is about quantity. And yet we make it about quantity all the time. So eternity is not simply lots of linear time. See, and that's another buzzword we can throw around. Another very loaded word is this word linear, because let's just kind of dive into it here. In the study of classical physics, right? What classical physics has discovered, primarily in the 20th and 21st century, the work of Einstein and some of his predecessors leading up to Einstein, but then Einstein and forward with his general theory of relativity and then his special theory of relativity. What Einstein demonstrated is that time is a physical quantity, right? It is a physical dimension. That's the better word. Time is a physical dimension, right? So when you listen to a physicist, if you're listening to any type of diligent physicist, he will very rarely use the words space and time separately. He will almost always refer to space-time, because space-time is the realm that we most readily recognize. Okay. So for example, I'm sitting here in front of my computer, sitting in front of the camera. You're watching me on the internet. And if I extend my hand away from myself towards the computer, we would call that depth, right? Or if I take my hands and I spread them apart side to side, we would call that width, right? And if I take my hands and I separate them high from low, we would call that height. So you got height, you got width, you've got depth. That's 3 physical dimensions. But then the 4th physical dimension is time. And it is these 4 physical dimensions that make up what we call space-time. And space-time is what we recognize most readily. Now, very interesting that what physics has also taught us is that in order to recognize a number of dimensions, you have to occupy at least one dimension greater. Okay? So if we can recognize 4 dimensions, 3 spatial and 1 time, then that means humanity must occupy at least 5 dimensions. And that is, for those of you that are my age, you're going to go right back to, right, the pop group from the 1960s and 70s called The Fifth Dimension, right? And that's exactly where it came from. That's exactly where it came from. That's where that phraseology comes from, is the insights of physics into our existence and into our reality. But my point here is that as a 5th dimensional creature, which we are, this isn't new age woo woo wacko out there. It's not. This is science, right? Now, isn't that interesting? Because for the last 2 or 3 years now, we've been getting beat over the head with follow the science, right? And usually that's simply a buzz phrase to try to end a conversation. But this is accepted science now. It might have been new age woo woo at one time, but this is now well established science, right? Now, what we're going to find out is that well-established science will lead you to some very interesting questions that maybe can't get answered, which is when, maybe that's where theology needs to take over. I heard a guy on the internet just the other day. He was talking about brain science, which was really cool, by the way. He was talking about brain science, and he was talking all about the biology of the pineal gland, right? Is that the one that produces melatonin, right? Which is what helps you sleep, right? And he was talking about the activity of the pineal. See, and I'm not a scientist. Like I said, he was talking about the activity of that gland, right? And that when certain things happen, they modulate the output of that gland, and then you get different, pardon me, enzymes or what the heck ever, right? But he was talking about the biology of this gland, right? And then where he moved to from there is he said, well, because this is also because it's melatonin, and that is the product, the enzyme, whatever the right word is, that helps you sleep. It's also involved in dreaming, right? So, and I'm a Bible believing Christian. There's dreams all throughout the Bible. So this is, so all of this starts to cross populate really fast, right? And cross pollinate. We'll use both words, right? Cross populate and cross pollinate really quick, where theology, biology, physics start to cross pollinate very quickly, because he said, this is how this gland works, and I'm talking about biology. But now when I start to get into dreaming, he says, frankly, I'm starting to talk about quantum physics, right? And what I'm suggesting is that once we start talking about quantum physics, to get certain answers, we may have to cross over into theology. That really is the most reasonable answer after biology and physics, is then theology. It may be the most reasonable answer. But at any rate, the reason I bring all that up about three spatial dimensions plus time is because these are physical dimensions. These are dimensions in space-time in what we would call the material realm. And the reason that's important is because they are all capable of modification. In other words, you can change the length of a thing, right? You can change the width, you can change the height. Guess what? You can mess with time. Time is a physical dimension, and time is subject to changes in mass, acceleration, and gravity. Okay? So if that's new to you, this is established science. Time is a physical property. It is a physical dimension. Time can be manipulated. And time can be manipulated according to mass, acceleration, and gravity. Now, it's in micro amounts, right? The experiments that they've done where they take atomic clocks and here's an example, right? My understanding is that there are two very highly accurate cesium atomic clocks in the world, one in Colorado, right? And one in England, one in Greenwich, England, right? And they're accurate to within 1/1,000,000th of a second a year, or some ridiculous kind of accuracy, right? And yet they're different. Okay, how does that work? Well, what do you mean you've got two hyper accurate clocks, right? And yet how can they be different? Well, it's because they're at different altitudes. And if they're at different altitudes, that means they are at different measures of gravity. See, one is 5,000 feet above sea level in the mountains in Colorado. The other one is 80 feet above sea level in Greenwich, England. Okay, so the difference is accounted for. It's absolutely accurate. It doesn't change the accuracy of either of the clocks. It's that the two clocks are a slight bit off from each other. And I just said they're accurate to what? 1/1,000,000th of a second a year, or some ridiculousness like that. Okay, well, that means the difference that they're off is like that as well. 1/1,000,000th of a second, some ridiculously small amount like that as well. But it's due to the changes in altitude, and therefore the changes in gravity. So now let's get on with this. So, like I said, oftentimes we think of God as out there, right? We think of the vastness of God. Okay, and I'm going to come back to that. When I get to the punchline of all this, I'm going to come back to the vastness of God, because I do believe God is vast. Okay, we have this expanding universe that is enormous, and yet God fills it, right? God fills it. But now what we're talking about is we're going the other way. Now we're going the other way. When you talk about quantum physics, quantum is small, right? Quantum is small. It's subatomic particles, right? You would have to actually use a metaphor or an illustration to help us describe exactly how small quanta are. Let's see if I can actually jump there in my notes. I actually wrote down an illustration to help us understand this, because sometimes it's very difficult without an illustration to help us understand just how small we are talking here, right? Let's see here. Where'd it go? Come on. Okay, here we go. Got it, right? So if you break apart an atom, now an atom, how small is an atom, right? How small is an atom? You got to put it under a microscope to see it. But if you break apart an atom into its constituent parts, one of the things that you're going to find out is the ridiculous size and volume difference between the nucleus, okay, and then the overall volume of the atom, right? So ready for this, because atoms are mostly empty space, okay? So the relationship between the size of the nucleus and then the volume of the atom, in other words, the overall size of the atom in 3 dimensions, right? The volume, right, of the atom is the same. This is how this is the size difference between the nucleus and then the external limitation of the atom, right? To help us understand it, it's the same as the difference between 1 second of time and 30 million years. That's the difference between the nucleus and the external measurement of the volume of an atom, right? And yet they're microscopic. So we're talking how subatomic is subatomic. But my point being is that quantum physics is talking about the limitations of how small, right? The limitations of how small. Whereas just a moment ago, we were talking about the vastness of God. Now we're talking about the opposite of vastness. But that doesn't mean God is small, but it means that does he occupy the smaller we go, we still find him, right? Because what I'm driving at here is that we're talking about physical dimensionality. We are talking about the material realm, okay? And it is limited, right? Now, this is science, okay? This is science. Once again, just like I said a little while ago, the super popular buzz phrase for the last 3 years has been follow the science, right? And that follow the science, frankly, has meant I'm going to shut down this conversation. That's what that phrase has been used to mean for 3 years now. And I was running into it long before 3 years ago, because I deal with a lot of skeptics in the field of theology, people who do not want to believe in theology. You got a lot of skeptics, so I get a lot of skeptics who are like, well, I'm just really into science. So they try to use, I've run into science, skeptics for decades who say, oh, I'm just really into science, because they don't want to listen to a theological argument. They claim to be into science, quote unquote, but really they're not even into science. They just use that phrase to shut the conversation down, right? So what I'm talking about here is science. This is hardcore verifiable science, right? Hardcore verifiable science that the material realm, the universe that we live in, is finite. Okay? Did you hear me? So that means as far as you go out that way, you eventually reach a point where it stops. Okay? Now the universe is expanding, okay, but it's not infinite. The universe is finite. And what quantum physics teaches us is that the smaller you go, you eventually reach a point where you cannot divide it any further. So both in vastness and smallness, the universe, the material realm, is finite. In both vastness and smallness, the universe, the physical realm, is finite. Now, what's really interesting, however, about when you look at the smallness, right, is that when you get to these indivisibly small measurements of length, mass, energy, and time, you get to the point where it's indivisible, right? And that you have discovered quanta, right? The indivisible, it's so small you can't cut it in half anymore. You can't subdivide the length, the mass, the energy, or the time any further, right? When you get to these quanta, when you get to these smallest of smallest of smallest of smallest particles, right? They lose their locality. Okay, okay, Tim, what did you just say? I just said they lose their locality. In other words, when they get to be that small, they exist everywhere at once. You can't pin down the location. Okay, now that sounds wacko, right? That sounds wacko, and it's supposed to, frankly, because the quantum physicists, the scientists who discovered and normalized this stuff, they wrestled with this language just like you are listening to me. If you talk about Einstein or Niels Bohr or Richard Feynman, right? Is that right? Feynman? Feynman, right? Feynman, in particular, has some really interesting quotes about quantum physics and how difficult it is to understand. And yet, he had a great sense of humor, right? That not only is quantum physics very difficult to understand, it's also undeniably true. It must be, right? And part of the reason we know that is because much of the modern technology that we rely on today relies on quantum physics, is how we were able to develop it. How we were able to develop things like microconductors and things like that is all due to quantum physics. But my point here is that the universe, what we would call the universe, or what we might call the material realm, right, is finite, both in its vastness and also in its smallness. There reaches a point out there where it stops, and there reaches a point under a microscope where it stops. Okay, well, why am I mentioning this? Well, the reason I am mentioning this is because let's talk about the word infinite, right? Because I just said that the known universe, right? The universe, the material realm, is finite. Well, that means by definition, it is not infinite. It is not infinite. It has a beginning and it has an end. Okay? And when you talk about time, right? Because I said there are indivisible units of length, mass, energy, and time. Okay, so that's a very, very interesting concept when it comes to the universe, is that scientists will tell you the universe had a beginning. Now, they're going to tell you that beginning was a big bang, right? But that's very problematic, because if you're talking about indivisible units of length, mass, energy, and time, then that means that the Big Bang Theory, by definition, basically goes like this. First, there was nothing, and then nothing exploded. Okay, well, how's that possible? How can nothing, literally no thing, how can nothing explode? Right? So how can the universe have a beginning and how can the universe have an ending, right, without there being a beginner, okay, or an ender? So really what I'm driving at here is I'm driving at that quantum physics. Like I said, I was listening to this guy on the internet the other day, and he was talking about the biology of the brain. And then because he was getting into things like dreams, right, the function of the pineal gland and melatonin, right? And then that's effect on dreams, right? So he went from biology to quantum physics, and now we have to go there. You got to go to theology, because ironically, quantum physics doesn't answer it, because the same guy, right, wanted to, what's the word I want to use? He wanted to get into how amazing the universe was. See, and this is my point. This is what I am driving at. This is the point that I'm driving at about today's subject matter, is that when you talk to skeptics, when you talk to New Agers, when you talk to atheists, a lot of them will embrace the power of the universe. They just will not embrace the idea of God. They don't want to go there. They don't want to talk about God. They don't want to talk about the Bible. They don't want to talk about a creator. They don't want to talk about anything like that. But they want to embrace, how amazing the universe is. But if the universe is finite and has a beginning and has an end, then what about the beginner? What about the end-or, right? The ender. And then, like I said, when you look at quantum mechanics and you realize that there comes a point where it's indivisibly small and it loses that particle, that quantum particle loses locality. It's everywhere all at once. Well, that's what a lot of these folks want to embrace, is they'll tell you, well, that's how amazing the universe is, that every particle in the universe is somehow connected to every other particle, because that is part of quantum physics as well. They have done experiments where they now realize that, and this is actually the fundamental paradox. And once again, I am not a scientist. I am not a quantum physicist. I'm doing my best to explain this in layman's terms to help us understand theology, to help us understand God, is that when you subdivide these subatomic particles and you get to the point where they lose locality, also the fundamental paradox of these subatomic particles, of these quanta, is how they behave, right? Because remember how I said classical physics is the observation of the behavior of material things, right? Quantum physics is the observation and behavior of subatomic material things, right? It's at the subatomic level. So we observe the behavior. It's all about the observation of behavior. And so when you get to the fundamental paradox of all of quantum physics, right? The fundamental paradox of quantum physics, the central paradigm, is the wave versus particle duality, because it turns out that these particles only have locality when we observe them. When we're not observing them, they also act like waves. What the heck? What does that mean? What does that even mean, right? Well, if you think about waves of water, right? And especially if you were to take, your classic illustration, you throw a pebble in the water, right? And the waves emanate out from the pebble, right? Well, what if I throw a pebble over there and I throw a pebble over there, right? Well, the waves are going to emanate out from both of these locations, and eventually these waves are going to interfere with each other, right? So that's a great illustration, because what quantum physicists have discovered is that these subatomic particles, these quanta, when you get to that indivisibly small particle, right? If they're not being observed, which is what makes it a particle and what gives it locality, right? Then it behaves like a wave, and it's not localized. It is, to use the theological term, it is omnipresent. It's everywhere at one time. Very, very, very interesting. So this wave versus particle duality is the central paradox of quantum physics. And this actually leads me to one of my favorite jokes. And I actually wrote a paper on this for my master's degree, because I was discussing, here you go, I was discussing the age of the creation, the age of the universe. Because according to some scientists, they're going to tell you that the universe is 16 billion years old. And yet you'll talk to some scientists and obviously some theologians who will tell you, well, no, the earth or the universe is 6 days old plus a couple thousand years, right? Okay, 6 days old, because you have the whole record of creation in Genesis that the creation took 6 days, right? Well, which is it? Is it 16 billion years or is it 6 days? And the answer to that question is yes. And I'm not being flippant. I'm using quantum physics to answer that question, because what observer are you talking about? Are the subatomic particles of creation, the subatomic particles that are the constituent pieces of matter at the subatomic level, right? If they cease to have locality unless they are being observed, well, you have to have an observer, right? And if they're not being observed and they're acting like waves, well, then that changes their behavior entirely. And all of a sudden, they don't have locality. All of a sudden, they are omnipresent, right? And this also, you got to go there, right? Like I said, we talk an awful lot about God being out there, right? That's probably the most common concept, okay, of God, is that he's out there somewhere. He's out there somewhere, right? He's distant. He's out there. And yet the consistent testimony of Scripture is that God wants to dwell within his creation, right? So now if we're talking about matter, right, and that you're subdividing matter until you get to the point where it can subdivide no more, and that then it loses locality, well, another word for that is omnipresent, right? So I'm asking, right, is this describing how the creator of the universe can be omnipresent inside everything and everyone? And I think the answer to that is yes. And like I said, we've now gone from biology to quantum physics to theology, that you need theology to answer the question, because frankly, this is what theology has been teaching for thousands of years, is that God is omnipresent. And God also is the creator. The universe, and I love pointing this out to my skeptic and atheist friends, right, is that the universe is finite. The universe is a created thing. I'm talking about the creator of the universe. The God that I worship, the God that I believe you should worship, okay, is the creator of the universe. They extol how amazing the universe is, and to become one with the universe, and da 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 da, and to operate the law of attraction, and to da da da, and all this stuff, right? Okay, but that's in a finite universe that's created by God, right? And then let me get there in my notes here. Let me read this off to you, because this is where I went in my mind when I think about this and when I meditate upon this, because I literally do meditate upon this, because I think this is the point. And this is the point that I want to make for you today, is that I find this monumentally encouraging. There is a song by the group Third Day, right? Called All the Heavens, I believe is the title of the song, right? And it's the second verse that goes like this. It says, all the angels exalt you on high. Talking about God. All the angels exalt you on high. What a kingdom to depart. But you, God, left your throne in the sky just to live inside my heart. And then it goes on to say, all the heavens cannot hold you, Lord. How much less to dwell in me? I can only make my one desire holding on to thee. And I think that is absolutely magnificent. That's really the point I've been driving at all this entire segment today, ladies and gentlemen, is that quantum physics to me helps me get a better picture of God. That the universe that we live in is finite. It's finite in its vastness. It is finite in its smallness. And yet all of it was created by the God of the Bible. And it's the God of the Bible that also created you and me. He created you and me and called us. If you are a follower of Jesus Christ, Ephesians tells us that we were chosen in him before the foundation of the world. And we'll talk about that in another segment, because before the foundation of the world, that's getting into that whole time is a physical dimension thing. So what's before the foundation of the world if time is a physical dimension and time is changeable according to mass acceleration and gravity? Right? Also, what does it mean when the Bible talks about the Lamb of God slain from the foundation of the world? See, so there might be some more segments on this. Don't know if I'm going to do it next week or not. You might want to tune in to find out. But I find this tremendously encouraging that the universe is actually finite, but that the universe was created by the God of the Bible. And the God of the Bible, not only is he so vast that all the heavens cannot hold him, but he is so intimate that he wants to make his home inside you and me. Well, there you have it, ladies and gentlemen. So kind of a very different episode today, talking about quantum physics and faith and eternity and infiniteness and all that kind of stuff. I hope this blessed you. I hope it did for you what it does for me. I'm Tim Keyes. Thank you for joining me on the Truth Be Told Radio Network, where you can hear my show every Friday night at 10 p.m. God save the King.